Welcome back to linear algebra. Let's jump into Anki. If A, B, and C are matrices for which AB equals AC, and if A doesn't equal 0, does it follow that B equals C? No. What condition must be satisfied for the matrix A equals A, B, C, D to have an inverse? And what is the inverse in that case? A times D must not equal 0. No. A times D minus B times C must not equal 0. The inverse in that case, oh, shoot, I forgot the formula. Isn't it 1 over AD minus BC? Matrix has an inverse if and only if AD minus BC does not equal 0. And the inverse in that case is 1 over AD minus BC times the matrix D negative BCA. Okay, didn't get that right. What are the coefficient matrix and augmented matrix of the linear system AX equals B? Coefficient matrix is A. Augmented matrix is A partitioned B. Good. All right, now I think that This is interesting. I think that I didn't finish any problems from yesterday, so I'll continue working and then I'll be back to recall what I did in a little bit. Okay, so we finished up that problem from yesterday. I had to use Quizlet because I was just done spending all this time. I knew I was making it too complicated. Anyway, what do we do? Okay, so to get from A to B, we only actually had to do 3 elementary matrix operations, or elementary operations. I did this on my own after I knew it was possible. And then to get C from this, apparently, here it is. Basically what we're going to do, if we have to take 3 operations to get from A to B, what is C times A equals B? What is C? We're going to just basically combine them all into one without multiplying. We're going to do, first we're going to take an identity matrix, add -2 to the bottom row, add -2 to the second row, -2 to the bottom row, and then -4 to the top row, also including multiplying by that -2. So that, which is interesting. That's very interesting that you can do stuff like that to manipulate a matrix. So that's just an interesting thing to know. 39. Given these 2 images of the standard basis vectors, find T of 1, 1. I believe that's pretty simple and straightforward. It would just be partition these together to get the standard standard matrix times the vector 1, 1. I believe that's probably correct. 41. This was given this is based on given a standard matrix. Find these based on inspection. We can know that the first column is going to be E1, E2, and E3 based on the way you can partition them, the images of the standard basis vectors to get the standard matrix. And then 43 was the one I was working on last that I didn't quite finish. Given these 3 reflection matrix, 3 standard matrix that cause reflection in 3 space, this over the XY plane, this over the XZ plane, this over the YZ plane. Basically find T1, 2, 3 and rational or convince yourself that it makes sense geometrically. So I'm not quite done with that, but yeah. That's gonna wrap it up pretty much for today. we're nearing the end of a first pass over 1.8. So that's it for today. Talk to you tomorrow. See you.